So previous session we have discussed number system conversions, right? Converting one number system into the another number system. Now this session you have two topics here, that is complements as well as subtraction of unsigned numbers, right? So you may get 2 marks questions or 5 marks question from these two topics, right? So first concept is complements, right? So what is this complements, right? So why we are using this complements means mainly the complements are used in digital computers to perform what? Subtraction operation, right? So which are used in logical manipulation. Any logical operation you want to perform, you need what here? So subtraction you are going to perform, addition, subtraction, like that. So this complements are mainly used in what here? Subtractions. That's why here they are given. Complements are used in digital computers, right? So for simplifying what? Subtraction operation. For simplifying what here? Subtraction operations which are used in what? Logical manipulation. Again this complements, again you have two types here, right? R's complement and R minus 1's complement. So that is only named as a true complement and radix minus 1 complement. So true complement is nothing but R's complement and radix minus 1 is nothing but R minus 1's complement, right? Already we know what is this R. R is nothing but what here? It is the base of the number system. Whichever number system you are taking, the base. If you are taking binary, R value will be 2. If you are taking octal, R value will be 8. If you are taking decimal, the R value will be 10. If you are taking hexadecimal, the R value will be 16 here. So you have what here? Two complements. One is true complement and second one is radix minus 1 complement, that is R's complement and R minus 1's complement, right? Here I have given the equations here for true complement, that is R's complement as well as the R minus 1's complement. So if you are taking this n as a number of digits or number of bits within the given number and R is nothing but what here? The base of the number system and n is the number, right? Whichever number you are getting, that one. So if you are applying these two complements for binary number system, right? So these two complements are applied for binary as well as a decimal number system, right? So binary, you know 2 is the radix and for decimal 10 is the radix. Then in that case you have two complements in both the cases, binary number system as well as a decimal number system. In case of binary here, I told R's complement, R minus 1's complement. So R's complement is nothing but what here? 2's complement and R minus 1, that is nothing but what? 2 minus 1, that is 1's complement, right? When you are coming to decimal number system, here you have again R complement, R minus 1 complement. So in case of this R's complement, that is nothing but what here? 10's complement and R minus 1 is nothing but what here? 9's complement, right? So these two complements are applied to what here? Two number system, binary number system, decimal number system. So binary radix is 2, so R's complement is 2's complement, R minus 1 is 1's complement. When you are taking decimal, it is what? 10's complement as well as the 9's complement here, right? So already you know what is 1's complement and what is 2's complement, right? 1's complement is nothing but what? You know, each bit, right? Each bit of a given number, when it is subtracted from 1, then in that case you will get what here? 1's. Or simple method you can take, that is nothing but converting 1's into zeros and zeros into 1's, that is nothing but what here? 1's complement. Now what is 2's complement? 2's complement is nothing but adding 1 to the 1's complement, that is nothing but what here? 2's complement. So here I have given, right? R minus 1's complement plus 1, right? So 1's complement you are adding 1, that is nothing but what? True complement. When you are coming to decimal number system, then in that case, so 10's complement and 9's complement. 9's complement how we are getting means each digit of a given decimal number will be subtracted from 9. Here I told 1's complement, each bit of a number is subtracted from 1. Like that only here, each digit of a decimal number is subtracted from 9. Then you are getting what here? 9's complement. After whatever number you are getting, that will be added with 1. Then you are getting what here? 10's complement. So this is about what? 1's, 2's, 9's and 10's complement. So that both only here I am going to explain with the help of what here? Example. Right? Here I have taken example ones and twos complement of the given number. So, binary number I have given, binary number, this number I have given. Now, in this case, right, so I have to find out what here, ones and twos complement. So, first what I will find out here, ones complement. Now, ones complement of given number. What is ones complement? I told, simple method, converting zeros into ones and ones into 0. 1 excuse me. Now 0 is converted into 1. 1 again 0. 1 0. 0 is 1. 0 is converted into 1. 1 is converted into 0. 0 is converted to 1. Right? Now 2's complement. Right? R minus 1's complement I got. Now it is what? R's complement. R's complement is nothing but what? You should add 1 to the R minus 1's complement. So 2's complement of given number is nothing but adding 1. So what you will do here? Add 1, right, to the 1's complement. I got already 1's complement. For this I need to add what here? 1. That 1 is added at which position? Means least significant bit. Already we know from this, right? This 1 is nothing but what here? Least significant bit. This is LSB and this is what here? MSB. Now least significant bit I have added what here? 1. Now here 1 plus 1, logical addition here. 1 plus 1 is what? 0 with carry 1. 1 plus 0 is again what here? 1. In this one, so as it is 1, here you have 0, here you have 0, 1, 0. Right? So 1's complement is this one and 2's complement is this one. Right? We got R's complement as well as R minus 1's complement for what? Binary number. Now here one more example I have taken, that is decimal number system. So decimal number system, what we have? 9's complement as well as a 10's complement. So I told given number, first I should find out what here? 9's complement. So 9's complement is nothing but what? Subtracting each digit of a given number from 9. So how many digits are there? 4 digits. So I am taking how many 9's here? 4 9's I am taking here. Right? After that, so this I have to subtract from this 9. So I am taking here 1, 2, 8, 9. Right? So 1, 2, 8, 9. So subtraction, subtracting each digit of a given number from 9 here, right? So, you are getting what here? 0. Now, here it is 1, here it is 7, here it is 8. I got. So, this is what here? This is 9's complement of a given decimal number. Now, I should find out what here? 10's complement. So, 10's complement is nothing but what? Adding 1 to the 9's complement, right? So, R's complement is nothing but what? Adding 1 to R minus 1's complement. This is nothing but what here? R minus 1. For this I have to add 1 here. So, I am adding 1 again at the least significant bit position. Now, what will get here? 0 plus 1 is 1. Normal addition. 7, 8. So, what is the 10's complement? So, 10's complement of a given number 1, 2, 8, 9 is 8, 7, 1, 1. Right? So, here one more example also I have taken. Why? Because this is new. Already you know 1's and 2's complement, but 10's and 9's complement now only are going to listening. So, 2 examples I have taken. So, second example is 2, 3, 4, 5. So, first step is what? Finding the 9's complement. 9's complement is nothing but what? Subtracting each digit of a number from 9 here. So, how many digits are there? 4 digits. So, I will take already 4 we had, no, right? Here I will take one more digit, that is 2. 2, 3, 4, 5, 2. So, how many digits are there? 5 digits. So, how many 9's you will take here? 5 9's. Right? Subtracting. So, I have to subtract this. 2, 3, 4, 5, 2. Right? Subtraction I have to do. Now, what will get here? 7. 9 minus 5 is 4. 9 minus 4 is 5. 9 minus 3 is 6. 9 minus 2 is 7. I got what? 9's complement. 9's complement I got. Now I should find out what here? 10's complement. So 10's complement is nothing but what? 9's complement plus 1. So here I am going to add at the least significant bit position. So what you are getting? 7 plus 1 is 8, 4, 5, 6, 7. So this is nothing but what here? Tens complement of a given number. So as it is here, you have here 1s and 2s complement, but here you have what here? 9s and 10s complement, right? So next concept we have, that is nothing but subtraction of. Next concept is what? Subtraction of unsigned numbers, right? So here I want to subtract what? Unsigned number, subtraction of unsigned number. So here I have taken m minus n. Subtraction is nothing but what? We are doing what? Subtraction. N is subtracted from m. So here this m I am considering as a minute, right? And n is considered as a subtrahend. Why? Because this is subtracted from m. So m is considered as a minute and n is considered as a subtrahend. So whenever you are doing subtraction of this unsigned numbers, you have to follow these 3 steps, right? First step is, see here, add minute. Minute is nothing but what here? M to r's complement of n. To what? M should be added. M plus r's complement of n. So if you are taking decimal number system, then tens complement of n. If you are taking binary number system, you have to take what here? 2's complement of n. So m should be added with what? 2's complement of n. So I am adding. So here I have given, see here, m plus, right? So I have to take what here? R's complement of n, right? That one. Next, second step is, you have to check, right, whether m is greater than n, right? If m is greater than n, right? So minute is greater than n, then in that case the sum will produce. I told m will be added to what? R's complement of n. So when you are doing that addition, it is going to produce what here? End carry. Carry 1 will be generated. Then that carry is going to be discarded and the remaining value will be the what? The result of the subtraction, right? So in this case no problem, carry will be generated, that carry is going to be discarded and whatever result, that is nothing but what here? The result of m minus n. And one more case you have, that is if m is less than n, right? If you understand these steps, then only you can go with the problems, other you cannot solve the problem, subtraction, right? If m is less than n, then in that case end carry will not be generated. If it is greater than n, then end carry will be generated and that carry will be discarded, the result will be taken. When m is less than n, no end carry will be given and whatever sum operation you are performing, for that you have to place, the result is placed with what here? Negative sign, and you have to find out once again the r's complement of the result, right? So these 2 steps you have to remember, right? First one is common for both the cases, whether it is m greater than n or whether is m is less than n. But if it is m greater than n, end carry will be discarded, the result will be m minus n. When it is less than n, then in that case end carry will not be generated. So once again you have to find out what here? R's complement of the result, right? So now based on these 3 points, now I am going to solve the problem, subtraction of 2 values, that is